Alright, so in this video, I'm going to solve the problem 2 to the power of 25 minus 1. So, to first start, I'm going to rewrite 2 to the power of 25 as 2 to the power of 24 plus 1. And then we have our minus 1 at the end. And the reason I'm doing this, and rewriting 25 as 24 plus 1, is so now I can use the property a to the power of m plus n is equal to a to the power of m times a to the power of n. So 2 to the power of 24 plus 1 is going to equal 2 to the power of 24 times 2 to the power of 1 minus 1. Now basically our goal throughout this video is to change our values to be as small as possible, so then at the end we can do whatever we need to do with them to get our final result. So 2 to the power of 24, how do we simplify this and make it even smaller? I can rewrite this as 2 to the power of 12 times 2. And another property of exponents is that if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So 2 to the power of 12 times 2 is going to equal 2 to the power of 12 to the power of 2. And I have this times 2 minus 1. So now I'm actually going to plug in the actual value of 2 to the power of 12, because 2 to the power of 12 is small enough where we know the exact value of it. So if you guys don't know what 2 to the power of 12 is, well, 2 to the power of 10, you should always remember this as 1024. So 2 to the power of 11 is going to be double of 1024, which is 2048. And 2 to the power of 12, which is the value we're looking for, is going to be double of 2048, which is 4096. So now I get 4096 squared times 2 minus 1. And now this is equal to, I'm going to simplify this, 4,000 plus 96 squared times 2 minus 1. And the reason I'm doing this is because 4096 squared is really hard to calculate by itself. So if we change it to 4000 plus 96 squared, I can use the property a plus b squared is equal to a squared plus 2ab plus b squared. So in this case, a is 4000 and b is 96. So this turns into 4000 squared plus 2 times 4000 times 96 plus 96 squared. And I have all of this minus 1. Oh, sorry, all of this times 2 minus 1. Now, 4000 squared is equal to 16 million. 2 times 4000 is 8000, and 8000 times 96 is equal to 768,000. And now I have this plus 96 squared, which is equal to 9,216. And all of this I have times 2 minus 1. So now I'm going to add all these up. So if I add all of these up in the parentheses, I get 16,777,216. So now I have this times 2 minus 1. So if I multiply this by 2, I get 33,554,432. And I have this minus 1, which is equal to 33,554,431. So this is my answer to this problem. Alright, so in this problem, I have x to the power of 4 is equal to 1. So I'm going to first start by subtracting 1 on both sides. So then these two cancel out. and I get x to the power of 4 minus 1 is equal to 0. Now x to the power of 4, I can rewrite this as x to the power of 2 times 2. And if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So x to the power of 2 times 2, I can write this as x to the power of 2 to the power of 2. Now I have this minus 1 is equal to 0. Now 1 is the same thing as 1 squared. So I have x squared to the power of 2 minus 1 squared is equal to 0. If I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, a is x squared and b is 1. So I have x squared plus 1 times x squared minus 1, and this is equal to 0. Now, remember how now this is equal to, this actually gives me two equations. I have x squared plus 1 is equal to 0, and I have x squared minus 1 is equal to 0. So for x squared plus 1 equals 0, I'm going to start by subtracting 1 on both sides. So these two cancel out, and I get x squared is equal to negative 1. Now if I take the square root on both sides, the square root of x squared is x, and the square root of negative 1, if you guys already know, is I. So I have positive negative I. And for x squared minus 1 equals 0, I'm going to add 1 on both sides. So I get x squared is equal to 1. If I take the square root, I get x is equal to positive or negative 1. So that's 2 more solutions. So these are my 4 solutions to this problem. Alright, so in this problem, I have x to the power of x to the power of 10 is equal to 400. So to start, I'm going to rewrite 400. Actually, before that, I'm going to rewrite 400 as 20 squared. And now I'm going to take the power of 10 on both sides. So now I have x to the power of x to the power of 10 to the power of 10 is equal to 20 to the power of 2 to the power of 10. Now, if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of n to the power of m. So in this case, we can think of x to the power of 10 as m and 10 as n, and I can switch these two places. So now I have x to the power of 10 to the power of x to the power of 10. And also, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So this is the same thing as 20 to the power of 2 times 10, which is 20. Now I'm going to let x to the power of 10 equal to the variable y. So now I have y to the power of y is equal to 20 to the power of 20. And a to the power of a equals b to the power of b. This means that a equals b. So y is equal to 20. Now remember how we let x to the power of 10 equal to y, meaning x to the power of 10 is equal to 20, and x is equal to the 10th root of 20. Alright, so in this problem, I have x to the power of 6 is equal to x minus 1 to the power of 6. So I'm going to first start by subtracting x minus 1 to the power of 6 on both sides. So these two cancel out, and I get x to the power of 6 minus x minus 1 to the power of 6 is equal to 0. Now I'm going to rewrite this as x to the power of 3 to the power of 2 minus x minus 1 to the power of 3 to the power of 2 is equal to 0. And if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, this can equal x to the power of 3 plus x minus 1 to the power of 3 times x to the power of 3 minus x minus 1 to the power of 3 is equal to 0. And now if I have something in the form a to the power of 3 plus b to the power of 3, this is equal to a plus b times a squared minus ab plus b squared. And a to the power of 3 minus b to the power of 3 is equal to a minus b times a squared plus ab plus b squared. So I'm going to rewrite this as x to the power of, x minus 1 times, x plus x minus 1 times x squared minus x minus 1 times x plus x minus 1 squared. And then we have this times x minus 1 times x squared plus x minus 1 times x plus x minus 1 squared. And these two are actually separate equations. So this is equal to 0 and this is equal to 0. So let's first start with this here. So x minus 1, these two x's cancel out. So I'm simply left with positive 1 times x squared plus x squared minus x plus x minus 1 squared. This is equal to x squared minus x plus 1, which is x squared minus 2x plus 1. So we have 3x squared minus 3x plus 1 is equal to 0. And to solve this, we can use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac over 2a, which is equal to 3 plus or minus negative 3 squared is 9 minus 4 times 3 times 1 all over 2 times 3, which is equal to 3 plus or minus the square root of 9 minus 12 over 6, which is equal to 3 plus or minus the square root of negative 3 over 6, which is equal to 3 plus or minus the square root of 3i over 6. So these are my two solutions.